Hello and welcome back to this channel. In today's video, we are going to see how to solve such problems. This is a problem on static equilibrium. Let's look at the problem. 4 blocks each have 2 forces acting on them. Which block is in equilibrium? So we are given 4 blocks A, B, C, and D, and we are asked which one of them are in static equilibrium. By observation, you can scan through each of these blocks and look at the nature of forces acting on them. If you look at block C, we can see both forces are acting from the same direction on the block. And then same with block D, we can see the 2 forces are acting in the same direction on the block. Right away, we can see that these 2 forces on block C are going to add up because they are all pointing in the same direction and acting on the block. In that case, we can eliminate option C. Option C wouldn't be in equilibrium because we have 2 forces that are pushing it to the right. So it is going to accelerate to the right. The net force is going to be to the right. And then with block D, which is a similar case as we saw in block C. However, these 2 forces are pointing in the same direction from right to left. Therefore, we can eliminate option D as well. We are left with options A and option B because we cannot directly say if they are in static equilibrium or not. We need to do some extra checks to make sure they meet the conditions of static equilibrium. For a rigid object such as this block or any of these blocks sitting and being acted upon by 2 forces, 2 conditions must be met. From Newton's second law, it tells us that the net force acting on the block has to be equal to 0. That is translational equilibrium. So this is the condition for translational equilibrium. That is, the total force or the net force, the vector sum of all the forces acting on the block must be equal to 0. And this condition must be met plus another condition before we can conclude if any of these blocks are in static equilibrium. Now, what is this second condition? It is also saying that the net torque on each of these blocks must be 0 before we can say they are in rotational equilibrium. These are the 2 conditions for static equilibrium to hold. First, the net force acting on the block must be 0, and second, the net torque acting on the object must be 0. In simple terms, for each block that we look at, there shouldn't be any translation, there shouldn't be any rotation as a result of these forces acting on the block. And this is true for the first 2 eliminations we made for block C and block D, because the net force on this block is going to be 2 newtons and to the right. So that is not equal to 0. And for these blocks, the net force is going to be minus 2 newtons to the left, and that is also not equal to 0. Now, let's go back to the 2 options that are left for us to test with these 2 conditions. So let's look at block A. We have block A sitting and then acted upon at this point by a force 1.0 newton to the right, and then at this point by a force 1.0 newtons to the left. So this is the center of the block. So let's check that the first condition, which is translational equilibrium, true. So for translational equilibrium to be true, the net force, that is the sum of all the forces acting on this block, is going to be this one to the right, which is positive, so plus 1.0 newtons. And then this is opposing that, so that is minus 1.0 newtons, and that is equal to 0. So the condition for translational equilibrium is satisfied. Therefore, that condition is met. The second condition we need to check is the condition for rotational equilibrium, which says that the net torque on this block must be equal to 0. However, if we look closely from the center of this block to each of these forces, we are going to have some distance from the center. And this distance r from this center to this point is perpendicular to this force. Again, we have a distance from the center to this point, which is also perpendicular to this force. So looking at this, there's going to be a net torque, which is going to be clockwise. So we are going to have a net torque of this force times r plus this force times r, okay? And that is not equal to 0. So the condition for rotational equilibrium is not met. Now let's look at block B. For block B, we have the two forces acting directly opposite to each other. So one force, which is 1.0 newtons, acting from left to right at the same level. From right to left, we have another 1.0 Newton force acting on this block. The center would be here. Now let's test the first condition. The net force must be 0. So in this case, what is the net force? We have 1 Newton to the right, which is plus 1.0 Newton. And then we have minus to the left, so minus 1.0 Newton, and that is equal to 0. And that is in translational equilibrium. What about the second one? So these forces, looking at the direction they are acting, they are parallel to the r's, okay, not perpendicular. So the torque is going to be the distance r, f, sine of the angle between r and f. So in that case, with this one, we are going to have a net torque of 0 because the angle between the r and the force is 0, which is not so here because the angle between the force F and r is 90 degrees and sine 90 is 1. So that is going to give us some torque. So in this case, we can see that for block B, the condition for static equilibrium is satisfied. So with that, we say the correct answer is option B. Alright, so this brings us to the end of this video, and this is a nice exercise to be able to apply the conditions of static equilibrium to determine if a system is in equilibrium or not, as we just saw with these blocks. Okay, if you enjoyed this video, give me a like, share, and also if you are new to this channel, please subscribe to this channel so we grow the community. Until then, I will see you in my next video.